everyone. I am Rebecca Michelle Gia, and together with my groupmates, we will going to discuss about the third step for casting model, which is the model split. First of all, I will going to discuss what is model split. Model split is the third stage in travel demand modeling. Can be expressed as a fraction, ratio, or percentage of the total number of trips. It is also known as modal share or mode choice, in which it is a common and widespread indicator in transportation engineering to evaluate transportation behavior. Model split models aim to determine modes given the travel demand between different pairs of nodes or zones. Model split involves separating or splitting the predicted trips from each origin zone to each destination zone into distinct travel modes. For example, through walking, bicycle, driving, train, or bus. Kintahay, moadto ka sa imong gikan ka sa imong balay, moadto ka sa somewhere else nga imong gusto padulngan. Pagawas nimo sa imong balay, it's either night and then nga dili ka diretso makasakay, magbaklay pa ka, magbaklay mangatang para masakay og tricycle or jeep. Na siya imong gina-separate ang imong mga travel modes, imong distinct travel modes adisir ka makadto sa imong final destination. Mode choice is the aspect of the demand analysis process that determines the number or percentage of trips between zones that are made by automobile and by transit. The selection of one mode or another is a complex process that depends on factors such as the traveler's income, the availability of transit service or auto ownership, and the relative advantages of each mode in terms of travel time, cost, comfort, convenience, and safety. Mode choice models attempt to replicate the relevant characteristics of the traveler, the transportation system, and the trip itself, such that a realistic estimate of the number of trips by each mode for each zonal pair is obtained. So, ang model split or ang mode choice kanang aspect siya sa demand analysis process nga mag-determine sa number of trips between zones that are made by automobile and by transit. So the whole trip nimo, ang mode choice mag-determine siya sa number sa pila ka trips nga imong gamit sa automobile or transit. No, ikapila ka nagsakay sa kanang mga public transit paingon sa mga destination zone or sa whole trip, pila ang oras nga gi-cover sa imong mga private automobiles. No, ang pagpili pod nimo sa imong mode nga gamiton is nakadepende siya sa traveler's income or sa availability sa transit nga imong nga sakyan. Usa pa ang travel time, ang oras sa imong mga pagbiyahe, ang cost, kung asa ka makaless, magamit ba ka sa imong mga private nga automobile or public transit, and comfort and convenience ug safety, no, kung asa ka mas comfortable kung magamit ba ka sa imong mga private automobile or mag-commute ka kay ang kasagara sab sa uban mas ang moingon sila nga mas sayon ug mas dali ang mag-commute kaysa sa magamit sa ilang private mga vehicles. So mao na siya ang mga factors nga makaapekto sa imong pagpili sa imong vehicles nga imong gamiton para pag-adto sa imong destination. These are the various factors nga maka influence sa ato ang choice of model of travel mode. Una, ang own personal characteristics. Nga under dira mao ang age, gender, income, or the car ownership. Sa own personal characteristics, it's either um, senior citizen ba ka or student ba ka, student fare. Kay ang mga senior citizen or student fare maka-discount sila sa fare or sa pamiliti nila sa public transportation. Ang ikaduha, characteristics of transport system. Under po dira ang travel cost, travel time, comfort, convenience, and the level of service or the prestige of individual and system as well. Andara kung ang pamiliti, ang travel cost or 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 maka maka less baka kung mag-commute ra ka or kanang mas masayon or mas mapadali ba kung magamit ka sa mga private vehicle. Sunod is ang trip characteristics. Isang purpose sa mga trip, kadugayon sa mga trip. Kung nagdali ka or kung kanang sakay ba kaayo, adira. Sunod, ang last is ang trip and characteristic, the home-based trip and the density of land use. Kintay sa imong pag-travel kung traffic ba kaayo siya or dili. Next is the main purpose of modal split analysis is to determine the proportion of total person trips expected to use in future horizon year. So ang main purpose gid sa modal split is modal split analysis mag-determine siya sa proportion sa kanang trip sa total trip sa tao. Kung sa ma-determine na sab niya kung expected use in future horizon year. Like for example, karon kanang nag-commute siya and takabalo in following years mas na-realize niya nga oy masayon man di ay ang kanang magkaroon og private car. So ang modal split analysis mag-determine na siya sa proportion sa travel mode sa total trip sa isa ka tao, no? Sa private cars, una private cars, ikaduha ang public transport facilities. Ang na-under dira sa public transport facilities mga captive transit rider. Ang captive transit rider naghimo siya sa trip pero wala siya access sa private nga vehicle. Nagdepende ra sila sa public transportation system. Ang ikaduha, choice transit rider, na siya pagpili kung mag-private vehicle ba siya or mag-public transportation na siya sa isa particular journey, no? Kung asa siya mas comfortable nga iyang gamiton, mag-private ba siya or sa public na lang sab siya. Siya ang duha ka butang nga na under sa public transport facilities. Next, ang factors affecting the modal split. Ang first nga maka-affect sa modal split is ang characteristics of the trips. Una, ang trip purpose. Ang purpose sa imong trip or ang purpose sa like for example, ang purpose sa imong trip mangadto ka sa imong work and mas prefer nimo ang mag-undergo sa or magsakay sa public transportation kay dili na ka malangay sa traffic kay ang uban nga mga sakyanan sa public transportation na sila kaugalingong ruta. So mas mapadali, mas masayon nimo nga mag-public na lang ka kay dili na ka mag-adto sa national highway mga ingon ana. Pareha sa Manila na ay LRT and MRT nga pwede ra nimo magamit nga dili na ka mag-adto sa EDSA ba. So next is ang trip length. Ang trip length, ang late trips nga mas kung kintay public transportation imong gamit, so kanang naay kung kintay mauli ka og late, so naay possibility nga dili na ka makasakay or lisod na nimo para sa imo mosakay kay ang availability sa sakyanan lisod na siya kay ang uban wala nay late nga mga travels sa kanang public transportation. Ang sunod, ang time kanus ka nag-undertake sa imo nga travel during that day, kanang sayo ba sa buntag or late na ba sa hapon. So mo na ang mga factors nga maka-affect sa modal split or sa separation sa imong nga travel mode within that day. And next is ang household characteristics. Sa household characteristic, under niya ang income. Private car are more frequent as the income increases. Kung kanang naana kay kanang ika-maintenance sa imong private car, so mas prefer pod mo dito ang sa private car tungod sa gihatag niya nga convenient and comfortable sa imo ang comfort sa imo para sa imo nga pag-travel. And next is ang car availability and or ownership, and household size and composition. Sa inyong panimalay, pila ka buok ang mobiyahe, pila ka buok ang permente mo gawas para magbiyahe. Yan, and next is ang life cycle. And next is ang zonal characteristics. Ang sa zonal characteristics, mga residential density, public transport increases as the residential density increases. So, sa kada balay, daghan day ang mugawas, permente mugawas. So, ang public transportation sab ni ana para ma-accommodate niya ang tanan. So, magkadaghan sad sila. And next is ang distance from central business district, and last is ang concentration of workers. Muna siya ang zonal characteristics, maka-affect sab ni siya sa modal split. Next is ang factors affecting modal split. Network next is ang network characteristics ka under sa factors affecting modal split. Accessibility ratio, travel cost ratio, and travel time ratio. For travel time by public transportation system, it is composed of the time spent walking to the public transport vehicle. Sa network characteristic ng public transportation system, ang oras ni imong gilaan para sa pagbaklay paingon sa kanang terminal sa public transport vehicle. The region means from home to bus station or mga station nga tuad dito ang parkingan sa mga public transport vehicle. Next is ang time spent nimo nga naghulat ka para sa public transport to vehicle. It is a journey time for one station to another station in the public transportation system. Ang oras nga imo nga ginalaan para sa pagbaklay paingon dito sa public transport vehicle and sa paghulat sa public transport vehicle para nga ikaw makasakay. From reaching the destination station, then you will take some time for walking to reach at your particular destination. This is how the travel time of public transportation system has been composed of various factors. Naman na siya. Sa network characteristics, oras nga gikwinta gikan sa imong pagbaklay gikan sa imong nga balay paingon dito sa station nga tuwa dito ang public transport vehicle. Ang next is ang sa private vehicle naman is ang oras nga imong nga gispent sa pag-drive, spent nga imong na ang oras nga imong na spent sa parking at the destination, parking sa imo ang pagpark nimo sa imo nga private vehicle pag-abot nimo dito sa imo nga destination, o sa oras nga imo usab nga gispend sa imong paglakaw gikan sa parking vehicle padulong dito sa imong particular destination kung asa na gyud ka. So mo na siya ang mga factors nga naka-affect sa modal split. Next is i-discuss sa ako ang partner na sa ako ang groupmate na ang types of mode choice models.
Types of mode choice models. Types of mode choice models. Since public transportation is a vital transportation component in urban areas, mode choice calculations typically involve distinguishing trip interchanges, is either auto or transit. Depending on the level of detail required, three types of transit estimating procedures are used. First is the direct generation of transit trips. Second, use of trip end models. And third, trip interchange models fit models. So first, the direct generation models. These transit trips can be generated directly by estimating either total person trips or auto driver trips. Based on the figure 12.8 is a graph that illustrates the relationship between number of transit trips by population density and automobile ownership per household. Here is the example of direct generation models. Estimating mode choice by direct trip generation. Determine the number of transit trips per day in a zone which has 5,000 people living on 202,350 square meter. The auto ownership is 40% zero autos per household and 60% one auto per household. Solution: calculate population density. 5,000 person is equal to, I mean 5,000 person over 50 acre equals 100 person per acre. To get the conversion of 202,350 square meter, we convert this to acre through this solution. 202,350 square meter equals 1 acre over 4,046.86 square meter is equal to 50,000, is equal to 50 acre. So from this figure, 0 autos per household, 510 trips day per 1,000 population, 1 auto per household, 250 trips day per 1,000 population. To get the total transit trips, we multiply 0.40 times 510 times 5 plus 0.60 times 250 times 5 equals to 1,020 plus 750 is equal to 1,770 transit trips per day. This 5, ika na siya sa 5,000 people. Kaning 0.40, this is the 40% zero auto per household from the given problem, and 60% one auto per household. So 1,770 transits per day. Next, trip end model, the second model. Models applied prior to trip distribution stage immediately after trip generation. No accountability of trip characteristics. Emphasizes on captive riders. Captive riders, those who don't have access to private cars. Then 4 medium and small size cities. Factors affecting the trip end model are income, family size and composition, residential density, location of zones relative to central business district, and zone accessibility. Trip end model advantages and disadvantages. Less difficult and less costly. Separate consideration of public transport and private car. reflects factors such as income, family size and composition, and employment. So we have disadvantages. Non-sensitive for future transit service, emphasize captive riders, not consider all trip generation characteristics. To determine the percentage of total person or auto trips that will use transit, estimates are made prior to the trip distribution phase. Based on land use or socioeconomic characteristics of the zone, this method does not incorporate the quality of service. So the procedure follows. First, generate total person trip production and attraction by trip purpose. So from trip generation sa first group, nag-report dito magkuha. Then compute the urban travel factor. Determine the percentage of these trips by transit using a mode choice curve. Apply auto occupancy factors. Distribute transit and auto trips separately. So the mode choice model shown in figure 12.9 is based on two factors, household per auto and persons per square kilometer. The product of these variables is called the urban travel factor. Percentage of travel by transit will increase in an S-curve fashion as the UTF increases. So this is the S-curve. Here we have transit model split by percent. In x-axis, we have urban travel factor, 1 over 1000 times by one household over auto times persons per miles square miles. Here's the example. Estimating tree production by transit. The total number of production in a zone is 10,000 trips per day. The number of household per auto is 1.8 and residential density is 5,860 persons per kilometer squared. Determine the percent of residents who can be expected to use transit. Solution. Compute the urban travel factor. So here's the formula for urban travel factor. First, we need to convert kilometer per square to miles per square based on the given formula. So 5,860 convert to miles per square is equal to 15,000, approximately 15,026% per mile squared. Then substitute this to the given formula. UTF equals, or the urban travel factor is equal to 1 over 1000 times 1.8 times 15,026 is equal to approximately 27. Use figure 12.9 transit mode split. The percentage is 45%. Here, 27 located here in the x-axis, then we get the 45%. Next, trip interchange model. Perform after trip distribution. The effect of modal choice on distribution is neglected. Focus on choice riders. Choice riders, sila tong have private car, but they can choose to ride in a public transit. For completing modes of transport, allocation of trip movements from trip distribution, level of services provided by transport system. Parameters of level of service are relative travel time, excess travel time, relative travel cost, relative level of service, economic status of trip maker. Trip interchange model. The advantages and disadvantages. So the advantages are useful in public transport planning, zone-to-zone usage of private vehicle and public transport. Disadvantages: more complex when the number of zones is large. Trip distribution is carried out before modal choice, not consider length of journey by car and public transport. So, interchange model. In this method, system level of service variables are considered, including relative travel time, relative travel cost, economic status of the trip maker, and relative travel service. An example of this procedure takes account of service parameters in estimating mode choice using the following relationship. So, here we have equation MS. MS means mode share. MS sub auto equals I exponent of B. B is an exponent which depends on trip purpose. I and J is the two zone, the between two zone. T is means transit. So MS sub T equals proportion of trips between zones I and J using transit. MS sub A means proportion of trips between zones I and J using auto. I sub IJM means a value referred to as the impedance of travel of mode M between I and J, which is a measure of the total cost of the trip. The impedance is equal to in vehicle time per minute plus 2.5 times excess time per minute plus 3 given 3 is given times trip cost in dollar over income earned per minute. B the exponent, yes, which depends on trip purpose, and M T for transit mode and A for auto mode. In vehicle time is time spent traveling in the vehicle, and excess time is time spent traveling while not in the vehicle, including waiting for the train or bus and walking to the station. The impedance value is determined for each zone per and present a measure of the expenditure required to make the trip by either auto or transit. Assume that the time was per year is 120,000 per minute. Example: computing mode choice using the QRS model. QRS means Quick Response System. Assume that the data shown in Table 12.21 have been developed for travel between a suburban zone S and a downtown zone D. Determine the percent of work trips by auto and transit. An exponent value of 2 is used for work travel. Median income is $24,000 per year. So here's the table. Distance for auto is 16 kilometers. For transit is 13 kilometers. Cost per kilometer is $0.09, while transit $0.06. Excess time for auto 5 minutes, transit 8 minutes. Parking cost $1.5 or $0.75 per trip for auto. Transit, no need for parking cost. Auto, the speed is 48 kilometers per hour, while in transit 32 kilometers per hour. Here's the solution. We use the equation 12.6. Mode share subs auto. So first we use the auto. Then I, the impedance of suburban to downtown in auto. So 16 over 48 times 60 Why we need to multiply 16 over 48 to 60? Because we need to get the minute. So, plus 2.5 times 5. 5 is the excess time of auto. 2.5 given na yan. Then, 3 times, plus 3 times 1.5 over 2 plus 0.09 times 16. So, 1.52 plus 0.9 is the trip cost. 16 is the distance. Then, over 24,000 divided by 120,000. This is the income earned per minute. So, here's the solution. 20 plus 12.5 plus 32.85 is equal to 65.35 equivalent in minute. Then, in transit, we get 13 over 32 times 60. Same sa auto. We need to multiply in 60 to get the minute. Plus 2.5 times 8 plus 3 times 13 times 0.06 over 24,000 divided by 120,000. Answer is 24.375 plus 20 plus 11.7 is equal to 56.075 equivalent minute. Then, we substitute this to the equation 12.6. So, 56.75 squared over this was given from the problem. 56.075 squared plus 65.35 squared times 100 is equal to 0.424 times 100. The answer is 42.4%. To get the mode share of transit, we can use this formula. Ms sub t is equal to 1 minus Ms sub a times 100. And the answer is 57.6%. Thus, the mode choice of travel by transit between zone S and D is 57.6%, and by highway, the value is 42.4%. These percentages are applied to the estimated trip distribution values to determine the number of trips by each mode. If, for example, the number of work trips between zone S and D was computed to be 500, then the number by auto will be 500 times 0.424 is equal to 212. And by transit, the number of trips will be 500 times 0.576 is equal to 288. That's all for the types of modal split.
Good day, everyone. I am Elmer Smilo Indin Jr. and I am going to report Logit model. A logit model, an alternative approach used in transportation demand analysis, is to consider the relative utility of each mode as a summation of each modal attribute. Then, the choice of a mode is expressed as a probability distribution. With this basic probability and utility expression and an assumed random distribution of the unspecifiable components of utility, a probabilistic choice can be derived and the coefficient in the utility functions can be estimated with the data collected from travel surveys along the same lines as for the coefficient in the trip generations model. To illustrate the approach, consider utility functions of the following form. The formula is V sub Im is equal to summation of k, bmk, exponent of z, imk plus epsilon IM, where V sub IM total utility, speciable and unspeciable, provide by mode destination alternative M to a traveler I, and BMK is equal to coefficient estimated from traveler survey data for mode destination alternative M corresponding to mode destination or traveler characteristic K. And Z sub IMK, traveler or mode destination characteristic K, income travel time of mode, commercial floor, space at destination, etc. etc. For mode destination, alternative M for traveler I, and epsilon IN is unspecifiable portion of the utility of mode destination, alternative M traveler I, which will be assumed to be random. For national convenience, define the specifiable non-random portion of utility V sub IM as UIM is equal to summation of K, B sub MK, and Z sub IMK. With these definitions of utility, the probability that a traveler will choose some alternative, say M, is equal to the probability that the given alternative's utility is greater than the utility of other possible alternatives. The probabilistic component arises from the fact that the unspecifiable portion of the utility expression is not known and is assumed to be random variable. The basic probability statement is P sub IM is equal to probability parentheses of U sub IM plus epsilon IM is greater than U sub IS plus epsilon IS for all S is non-equal to M, where PIM, probability that traveler I will select alternative M. Notation for probability. S is equal to for available alternatives, and other terms are as defined previously. A popular approach for deriving for the probabilistic choice model is to assume that the random unspecifiable component of utility, generalized extreme value distributed with the assumptions are rather lengthy and involved derivation gives rise to the logic model formulation. So the formula is, the fourth formula is P sub IM is equal to E raised to U, then IM over the summation of S EU IS, where E is the base of the natural logarithm. The coefficients that compromise the specifiable portion of utility are estimated by the methods are maximum likelihood. See Appendix 8B for further information. Logic model coefficient estimated and maximum likelihood estimated techniques refers to specialized references. With a total number of vehicles, base trips made in specific time period known, the allocation of trips to vehicle-based modes and likes destinations can be undertaken by applying appropriate logic models. This process is best demonstrated by example. Example number 1. A simple work-made choice model is estimated from data in a small urban or area to determine the probabilities of individual travelers selecting values. The mode choices include automobile drive alone, automobile shared ride, and bus. And the utility functions are estimated as U sub DL is equal to 2.2 minus 0.2 times cost sub DL minus 0.03 travel time DL. So U sub SR is equal to 0.8 minus 0.2 times cost SR minus 0.03 travel time SR. UB is equal to negative 0.2 times cost B minus 0.01 travel time B. Where cost in dollars and travelers time is in minutes between a residential area in an industrial complex for 4,000 workers, generating vehicle-based trips. Depart for during the peak hour for all workers, the cost of driving automobile is $6 with a travel time of 20 minutes. And the bus fare is $1 with a travel time of 25 minutes. If the shared ride option always consists of two travelers sharing costs equally, how many workers will each move? The solution is, note that the utility function coefficient logically indicate that as modal cost and travel times increase, modal utilities decline, and consequently so do modal probability substitution of cost and travel and values. So darang example, UDL is equal to 2.2 minus 0.2 times 6 mao ni ang dollars sa automobile minus 0.03 times 20 mao ni ang pagbiyahe sa travel time. So equal to 0.4. Sa USR, 0.8 minus 0.2 times 3 minus 0.03 times 20 is equal to negative 0.4. Then sa UB is equal to negative 0.2 times 1 is minus 0.01 times 25 is equal to negative 0.45. Solution. Substitution these values into equation for yields. P sub DL is equal to E 0.4 over E raised to 0.4 plus E raised to negative 0.4 plus E raised to negative 0.45 is equal to ang kuwada ni ang value niya sa E raised to 0.4 is equal to 1.492. So mao ni siya ang value po ng E raised to 0.4 mo pa ang value niya. Then plus E negative 0.4 is value po ng 0.670 plus E negative 0.45 ug 0 mo ni ang value niya sa 0.6380 is equal to 1.492, i-add mo siya tanan is equal to 2.80. So kuha na po ito siya, divide na po ito 0.533. So now, ito ipadayon ron, kung saan ipagkuha sa PSR is equal to 0.670, mao ni siya ang value yung coefficient over sa equal sa 2.80. So is equal to 0.239. And PB is equal to 0.638 over 2.80 is equal to 0.228. Multiplying these probabilities by 4,000, the total number of workers departing in the peak hour gives 2132 workers driving alone, 959 sharing a ride, and 912 using a bus. Forecasting mode choice with a logit model. Example number 2. A bus company is making costly efforts in an attempt to increase work trip bus usage for the travel conditions described in example 1. exclusive bus lane is constructed that reduces bus travel time to 10 minutes and that bus fare is reduced to excuse me, $0.50. After the lane bus construction, the model utilities of driving alone and shared ride are unchanged from those example 2. However, the bus model utility become U sub B is equal to negative 0.2 times 0.5 minus 0.01 times 10 is equal to negative 0.2. From equation 4 with 400 work strips, PDL. P sub DL is equal to E raised to 0.4 and E over the E raised to 0.4 plus E raised to negative 4.4 plus E raised to negative 0.2 is equal to 1.492 over 2.981 is equal to 0.5 and 0.500 times 400 is equal to 200 trips. And PSR 0.670 over the 2.981 is equal to 0.225 and 0.225 times 400 is equal to 900 trips. PB is equal to 0.819 is over 2.981 is equal to 0.275 and 0.275 times 400 is equal to 1,100 trips, or an increase of 188 bus patrons from prediction of example 1. B. With the right bus lanes open to shared ride vehicles, only the modal utility of shared rides will change from those in part A to USR 0.8 minus 0.2 times 3 is minus to 0.03 times 10 is equal to negative 1 from equation 4 with 400 work trips. P sub DL is equal to E raised to 0.4 over E raised to 0.4 plus E is negative 0.1 plus E is negative 0.2 is equal to 1.492 over 3.216 is equal to 0.464 and 0.6464 times 400 is equal to 1,856 trips. And PSR is equal to 0.905 over 3.216 is equal to 0.281 and 0.281 times 4,000 is equal to 1,124 trips. And PB is equal to 0.819 over 3.216 is equal to 0.255 and 0.255 times 400 is equal to 1020 trips, or a less of 80 bus patrons and a gain of 224 shared ride users related to Part A. With free bus fare, the bus modal utility becomes with the other utilities unchanged from Part B. UB is equal to minus 0.2 times 0 minus 0.01 times 10 is equal to negative 0.1. From equation 4 with 4,000 work weeks, P sub DL is equal to E raised to 0.4 and E raised to 0.4 plus E negative 0.1 and plus E raised to negative 1. 1.492 over 3.301 is equal to 0.452 and 0.452 times 400 is equal to 1,808 trips. And PSR is equal to 0.905 over 3.301 is equal to 0.274, and 0.274 times 4,000 is equal to 1,096 strips. And PB is equal to 0.905 over 3.301 is equal to 0.274, and 0.274 times 4,000 is equal to 1,096 strips, or 76 more bus patterns compared with part. Consider a residential area into shopping centers that are possible destination from 7 to 8 p.m. On Friday night, 900 vehicle-based shopping trips leave the residential area for the two shopping centers, a joint shopping trip, mode destination, choice logic model. Choice of either auto or bus is estimated giving the following coefficient: variable, auto constant, travel time in minutes, commercial floor space in thousands of feet squared. Auto coefficient 0.6, negative 0.3, and 0.012. Bus coefficient 0.0, negative 0.3, and 0.012. Initial travel times of shopping centers in 1 and 2 are follows. Travel time to shopping center 1 in 1 minute by auto, 8 minutes, by bus, 14 minutes. Travel time to shopping center in minutes, 15 minutes by auto, and 22 minutes by bus. In shopping center 2 has 400,000 feet squared of commercial floor space. In shopping center 1 has 250,000 feet squared. Determine the distribution of Friday night shopping trips by destination in both. So the next one is summary. In general, the modal split is a common and widespread indicator in transportation engineering that will evaluate the transportation behavior. The key aim of modal split is to distinguish the travel mode that trip makers, or in the case of crime offenders, use in the traveling between an origin location and destination. In other words, the modal split shows the percentage of trip makers using a particular mode of transport compared to the ratio of all trips mode. And that's all. And once again, thank you.